We know the intermediate representation corresponding to Boolean expression. Now let us clear how translation scheme syntax directed definition can be used to implement three address representation corresponding to Boolean expression. Expressions are evaluated from left to right. 1 denote true and 0 denote false. Consider this expression A or B and not C. What are the operators here? Or and not. Which operator having highest precedence? Not having highest precedence, then and, then or. So in the three address representation, which operator has to be done first? Not C. That is T1 is equal to not C. Now we can perform AND operator. T2 is equal to B and T1. T3 is equal to A or T2. Another example, A less than B. If A less than B, output is 1, otherwise 0. If A less than B, go to 103. Then we assign true. Otherwise, T equal to 0 and we have to go out of this if condition. That is, go to 104. Certain assumptions are done. Emit is a function which produces three address statement. Next state gives the index of next three address statement. Emit increments next state after producing each three address statement. E dot place. Place is an attribute of variable E which holds the value at E. New term is a function which creates a new temporary variable. Syntax-directed translation for producing three-address code corresponding to Boolean expression. Boolean expression contains logical operators like or, and, not, and relational operators. Boolean expressions can be E gives even or E2, E gives even and E2, E gives not even, E can be even. Here, for constructing the syntax-directed translation, first we have to construct the context-free grammar and then we have to write corresponding semantic action. E gives even or E2. The corresponding semantic action is when we see this E gives even or E2, we have to create a temporary variable to store the value of even or E2. E dot place equal to new temp. New temp is a function which creates new temporary variable. E dot place. Place is an attribute which holds the current value of E. Emit. Emit is a function which creates three address statement. So emit E dot place equal to even dot place or E2 dot place. E gives even and E2. E dot place equal to new temporary variable. Then we have to create three address statement. Emit E dot place equal to even dot place and E2 dot place. E gives not even. For storing the result, we need a temporary variable that is created by new term. E dot place equal to new term. Emit E dot place equal to not even dot place. E gives even. Here there is no need of new temporary variable. Whatever be the value of even, that get assigned to E. E dot place equal to even dot place. Boolean expression can be ID1 relational operator ID2. For example, A less than B. What is the three address code corresponding to this Boolean expression A less than B? This Boolean expression can be either true, that is 1, or can be false, that is 0. This statement can be represented as if A less than B, if it is true, T equal to 1. The address is 103. If A less than B, go to 103. Otherwise, T equal to 0. Then we have to go out of this if condition. That is 104. Go to 104. These are the set of three address statements to be created for this Boolean expression A less than B. So we have to write semantic action for creating these three address statements. Here we require a temporary variable t that can be created by new temp. E.place equal to new temp. Emit if id1.place, that is a here if a relational operator is less than, if a less than b, that is written as general if id1.place relational operator dot op id2.place go to 103. How we got this 103? For the explanation, these are all the three address statement corresponding to statement preceding a less than b. Then the next three address statement index is 100. That will be stored in next state, and from this statement, if this expression is true, we have to go 103. So this 103 is 100 plus 3. Next state gives this 100 and 3 we know, that means go to next state plus 3. Each emit statement, after generating a three address statement, it increments this index. So the next address is 101. Emit e.place equal to 0. E.place is t here. T equal to 0. Emit increments index. Now 102 emit go to next state plus 2. That means from next state 104. 104 is equal to 102 plus 2. From where we get this 102? 102 is the address here. 102 plus 2. Then it increments three address statement 103 e.place, that is t equal to 1. E gives true. E.place equal to new term, that means e.place equal to 1. E gives false. E.place equal to new term. Emit e.place equal to 0. After constructing the parse tree, when we start traversing, when we see a less than b, we have to perform corresponding semantic action. So we have to create a temporary variable. For example, we have created t1. If a less than b, is true, t1 equal to 1. Otherwise, t1 equal to 0. After this a less than b is over, we have to check c less than d. So 104. If c less than d, what we can write? We can write t2 equal to 1. If c is greater than d, we can write t2 equal to 0. Then we have to go e less than f. That is 108. In 108, we are comparing e and f. If e less than f, go to t3 equal to 1. If e is not less than f, t3 equal to 0, then we are going to 112. In 112, what we have to do? Now we got a less than b result in t1. This result in t2 and e less than f in t3. Now considering the precedence of operators, first we have to perform T2 and T3. T2 and T3. That is T4 is equal to T2 and T3. See here E1 and E2. E1 and E2. E.place equal to new term. That means now we have variables T1, T2, T3. We have created T4. T4 is equal to E1 dot place, that is T2. E2 dot place is T3. T2 and T3. Now we got the result T4. Now we can perform T1 or T4, E1 or E2. We have to create new temporary variable, that is T5 is equal to T1 or T4.